Good day to you. From this video onwards, I am going to make a series of videos in the subject of electronics. This is mainly for non-electronics people who don't have a chance to go into the formal education in electronics. So this series of videos only for them. Those who have had formal electronics may find this very fundamental, and then you won't find this interesting. Of late in IoT, many are practicing in this domain. They may be from non-electronics field, many may be from computer science or some other stream, but they would like to have some understanding about the devices they are handling it. So this series of videos is for them, and then most of the videos will be less than 10 minutes, around for 5 minutes, 6 minutes. It is a coffee time videos. By the time you have a coffee, you can finish off one video. So that's the purpose of such a small video. Enjoy and then subscribe to this channel so that you can view more such videos in the coming days. So I will be covering right from resistance to microcontrollers. This is the range I want to cover in this series of videos. First, let me start discussing about what is voltage and what is current. I have even seen that many graduated students, or at least undergraduate students, even do not have very good understanding of what is voltage or what is a current. So I can explain, let me start with voltage. Voltage is something like a potential energy which has been stored in somewhere. So the best example of a stored energy is water stored in a overhead tank. So that is energy has been stored in that area. In coming to electronics, it is something like a charge stored in a battery or charge stored in a capacitor. Let us see what is capacitor in the coming days. It is voltage is equivalent to energy stored. It is measured in terms of volt. Higher the volt, higher the energy. Normally you can say higher the volt, higher the energy. Okay. It may not be very true, but generally it is true. Higher the voltage, higher the energy. So this is what is voltage. This you can the analogy is water stored in the overhead tank. So you can assume voltage equivalent to that area. Now let us see what is current. Current is flow of electrons. Generally it is taken as a current flows from one direction. The electron flows direction, the current direction will be the opposite to this one. So that is the convention. So if I assume that electron flows from top to bottom, the current flow direction will be bottom to top. So this is the convention used to keep the current flow direction. So when there is a volt, let us go back to this once again, the overhead tank analogy. If there is a pipe, and then if you open the water through the pipe, the water will flow. The same thing, if you make a circuit from the battery or capacitor, current will flow through the circuit. So this is a flow of current, flow of electronics is current. Storage of electrical energy is voltage. So you can have it in that way. Though many people don't even able to find a difference between voltage, what is current. So let me repeat again so that you will keep it in memory. Potential energy, so electrical energy stored somewhere, you can say it is voltage. When the electrons flows due to voltage, then it is called current. People will say how you will store AC current or AC voltage. AC voltage is nothing but another variety of DC. DC volt with varying amplitude in both positive and negative direction with respect to time. That is AC. So now let me discuss what is AC and what is DC. DC has always polarity, positive and negative. So battery has a polarity, battery has a positive point and a negative point. But AC there is no positive or negative point. It generally, if it is single phase means it is phase and neutral. Phase and neutral is only for convenient purpose. But theoretically speaking, there won't be any difference between both phase and neutral when they are in operations. So AC is that the voltage value will be varying with respect to time. It will go positive as far as negative cycle. The best example is a sine wave waveform. I will show the waveform here. And this is the most popular AC voltage available all over the world. Certain places we use 50 Hz and certain places they use 60 Hz. I don't know what is the fundamental reason why this type of two types of frequencies. There is not much of technical advantage between 50 or 60 because they are very close to each other. There may be some advantage may be there if it is 50 Hz or 100 Hz, but between 50 and 60 I don't think there will be much of technical advantages on that one. But there are two standards followed in the world, 50 Hz and ASTM. So let me say once again, DC will have polarity, positive and negative. AC there is no polarity, but for the sake of convenience we keep one voltage as a phase and another as a neutral, phase and neutral. So the AC we have two types, single phase circuit and three phase circuits. So three phase will be, all three phases will be are noted as R, Y and B. So I will show you the waveform of the three phase so that you can understand. So voltage difference between each phase will be, there will be voltage difference between each and every phase, all will be equal. Between R and Y will be same voltage will be equal. Between Y and B same voltage, and then B and R once again voltage will be very same. So this is three phase voltage. In a vector notation there will be 120 degrees phase shift between each phases. So if you see the waveform, you can understand how the three phase voltage varies with respect to time and with respect to each other phase also. So you can pictorially see and understand what is three phase, and then you can understand what is single phase. So this is all about voltage and current, and then next video I will talk about only resistance. Thank you for watching. This is Kadal Amudam from Chennai. Good day to you. Do not forget to subscribe to the channel so that you can view more of these videos in the coming days.